This is Advent of Code 2020, day 20, and the puzzle is called Jurassic Jigsaw. So we are on a high-speed train on our way to the next part of our trip, and we decided while we're waiting on this train ride to take a look at the satellite imagery that we helped with in the previous puzzle. And we realized that the satellite messages are coming through all jumbled up. So what we want to do is take this array of camera images and reassemble them in a way that makes sense so that we can see what the image is. So each of these tiles has been sort of randomly rotated and flipped. So we need to take each of the tiles and rotate and flip them in such a way where they can line up into a square grid. So in this first example that they give us here, there's, I believe, 9 tiles in total. So it's going to be there's 16. So there's going to be a 4x4 grid. Or no, I was right the first time. There's 9. It's going to be a 3x3 grid. And so what we're going to need to do, if this was our puzzle input, is to go through and figure out how do these borders line up with the borders of other tiles. And we'll have to do that considering all the different rotations and orientations of the tiles. And eventually we'll find something that looks like this, that lines up all of the tiles. And so you can see that this right border here matches up with this left border here. So we know that they go next to each other. We also know that it fits in with this tile here because this bit lines up with these, so on and so forth. The outer edges don't matter. It's just any of the interior stuff where tiles are touching tiles, we need to make sure that they line up in all those spots. Hashes to hashes, dots to dots. And then at the end, you would have sort of this grid that is made up of the IDs that reference these different image tiles, and we take the 4 corners, multiply them together to get some sort of massive number that is our answer. So as I'm thinking about how to approach this puzzle, I'm noticing a few things. First is that, well, consider this tile right here, which lines up with 2, 3, 1, 1. So this first tile right here starts with ... 3 hashes ... 3 more hashes. So if I scroll all the way back up to this 2, 3, 1, 1, we see ... 3 hashes ... 3 hashes. So that in the orientation of the solution, this was actually all the way up here. And had it been a rotation, had we like rotated it 90 degrees and then another 90 degrees, these 2 dots would be over here. But in fact, in the solution, these 2 dots were positioned right here, which means that rather than rotating the tile, in this particular case, it was like flipped. So we're going to have to consider, as they told us here, that these tiles can be rotated, 90 degrees at a time, or they can be flipped, which means that for each tile, we have 8 different orientations we have to consider. Taking this into consideration again, this is the first orientation. Then we could rotate it 90, and now that's the second. We could rotate it 90 again, that's the third. Rotate it 90 again, that's the fourth. But that's just for that side. If we were to flip the tile over, then we'd have 4 more of those rotations. So for each tile, there's 8 possible orientations in total. Yeah. Just trying to think through what are the other pieces we want to... I guess I'm curious if we pop open the puzzle input. These tiles look about the same size, so that's nice. And then I'm curious how many tiles there are. If I do Command F and search for tile, okay. So there's 144 tiles, which means we're dealing with a 12x12 grid. So that's quite a jump up from the 3x3 grid that the example showed. So I'm going to Command A and copy this over, and we will create our input txt file, and I will paste this in here. Okay. So that's all pasted in, and I'm gonna split open part1.ruby. I'm gonna save that because I didn't. And yeah, let's see. We'll do some of the, or before I do it, oops, not paste. Just gonna sketch out a possible way of approaching this. So as per usual, we're going to have to parse apart the input file. Then we are going to read all the input data into some sort of data structures. I'm not sure if it's just arrays or if we're going to want some sort of object for them, some sort of defined class. Then I think we're going to have to do some kind of exhaustive tree search with backtracking. I don't know of a sort of non-brute force approach to this. I imagine we just take the first tile and we put it in the 0, 0 position in its first orientation, and then we see if there's another tile that can go next to it. And we keep going until we find that there's no tiles remaining that can fit. And then we backtrack to the previous choice, rotate any remaining rotations, continue forward. If we hit another dead end, backtrack some more. Probably eventually we'll backtrack to the first tile, remove that, and have to place in another first tile. So I think that kind of exhaustive brute force approach is going to be required here. I can't think of a more clever way to attack this problem. Ultimately, we'll get to, after placing the final tile in a valid orientation, then we will, I don't know, exit the search with our completed grid, and then grab the 4 corners and multiply the IDs and return that result. That'll be our answer. So at a very high level, this is how I'm thinking about approaching the problem. I'm going to get parsing out of the way. So we will read in the file. Oops. Input.txt, and then unparsed tiles. Yeah, unparsed tiles gets file.split, and we'll split on double new lines because like new line, one more new line. So that'll allow us to separate between each of the tiles. So we'll do like that. That'll give us each of our unparsed tiles, and then we will turn those into, maybe we can take that a step further. So we'll map that. What do we have here? Just like a chunk. That's not very descriptive, but oh well. Chunk dot split. Not quite. It's like I want the first line and then I want the rest. Like I want to grab off the tile part and then I want the rest to be separate. Is there a way to just like split the first? Oh, split takes a second argument. That's cool. So tell it to only split into 2 things. Oh, that's handy. I'm gonna upload that. Okay, chunk.split, and we will split on a new line, but only into 2 parts. And so then at this point, unparsed tiles will be a array of tuples where it's the unparsed title and unparsed tile data, something like that. Okay. Put that on a new line, and then, yeah, I'm starting to feel like I do want to turn this into some sort of tile class where we initialize it with an ID, tile data. I guess those would be the only two things that would come in. And then gonna assume that tile data is unparsed string. So maybe we can do the parsing here. Imagine this whole blob just comes in as is, and we let tile handle that. Or maybe not. Maybe that's not a concern that this class needs to have. Okay, let's backtrack that. So we'll say that the ID, it's ID, the tile data, it's tile data. What are the other considerations? I think we have to consider like the different orientations. So I guess the initial orientation is going to be, I don't know, like 0 degrees, and orientations could be, 0 degrees, 90 degrees, 180 degrees, and 270. And then I think it also flipped. It starts as false, but it could be true. Yeah. Okay. And we can use that. So we can use these two things, orientation and flipped, to kind of derive. We would take the original tile data here and we could derive kind of what the tile would, how that tile would be oriented, and what borders we can be looking at for top, right, bottom, and left. Yeah. So yeah, I'm imagining we're gonna have what I just said: def top, def right, def bottom, and def left. And so each of those would return, like top would return something like that. So we'll get to those, but just wanted to define them. So initialize these things. What else do we want to know about the tile? Yeah, I'm wondering, do we actually want to represent the tile data in its like current orientation, or do we always want to like derive it based on these two values? Yeah, I kind of want to just extract the borders, I guess. So I guess the borders would be maybe not like that. Maybe as a hash. So you can imagine like borders, we get the top, which is tile data 0. Yeah, that whole row. So if we imagine the tile data is parsed into a 2D array, we'd grab that whole first row, which would represent this whole thing. The bottom would be tile data last, tile data first. The right is going to be a little trickier because we want the last of each row. So it's like tile data dot map row dot last. Yeah, and so then left will be pretty similar. It'll be just row dot first. Okay, so we derived the borders for this initial orientation, and then maybe we want like a rotate function, which would update the borders. So yeah, I'm thinking if you were to rotate, not like the next thing in this array. Yeah, I'm just thinking update the orientation to be plus 90 degrees, basically. Oh, that's TM. I don't remember what degrees is. Then we would, then we'd have to do something. So I guess top would become the right. Because you imagine this just rotates like, you imagine it's rotating down, like if we were just kind of like cranking it to the right by 90 degrees. The right kind of gets turned upside down and points this way, so actually reading it left to right is the reverse of what right is, because this one is now going to be here and this one is going to be here. So it's like, yeah, maybe this is, instead of talking about it this way, we say the right becomes top, and the bottom becomes the reverse of the right, and then the left becomes, yeah, this would go here, and this would go all the way up here on the left. So reading top to bottom, that's still the same as the bottom, so that stays the same. And then the top, I believe, is going to be the reverse of the left. So those are the sort of operations we need to do a rotation. So let's see. It's going to be similar to this right here. We'll say yeah, I'm trying to think if I need to do a bunch of temp variables or if this can all happen in line. I don't know if these things are gonna, yeah, I think I can do it all in line. So borders is going to become borders left dot reverse. So that's what top is going to become. Right is just going to become oh, I didn't put commas after any of these things. That's going to be a problem. Okay. Then right is going to become borders top per this line 26. Bottom is going to become borders right reverse, and then left lastly is going to become borders bottom. Okay, I have commas after each of those, and I did not yet figure out setting the orientation, so if I pry, if I have A, B, C, E, orientations, if I say index of I wherever it's B, do you mean index? I don't think so. Okay. So if I find that that's 1, then I know that I want to update it to be, or it's 1 plus 1, which is C. That's good. What if I find that it's D though? And so I get 3. What's 3 plus 1? That's nil. So it's like I need it to wrap around. So I guess I could do this addition, and then we could mod it with the orts.size. Okay. So we'll do something like this, and then this. Okay. So let me exit out of here. Delete that. So let's find current orientation position gets orientations index equals orientation, and then we take the current orientation position, add 1, mod it with orientations.size, and we say that orientation gets that position from the orientations. Okay. Yeah, that's kind of a lot there, so that's why I was having trouble thinking about it. Guess we don't need that comma. So like this, rotate, I put the bang on the end because it is going to modify the state of this class. And then I guess we also need flip, which will similarly, oh my goodness, similarly will end in a bang since it's destructive. And yeah, how will that work? Something similar here. And I guess we'll say flipped gets not flipped. So we just have to change it to whatever it isn't. If it's not flipped, then it's now flipped. If it's true, then it's now false. And how do these rules change? I guess top just becomes bottom and bottom just becomes top. And then I guess the left and right, they just get flipped upside down, so they just get reversed, but they aren't trading. So left just gets left reverse and right just gets right reverse. Okay. like that. Bottom gets top, and then left gets left, reverse. Okay. I like these. These look like they're gonna work. Top gets borders top. Right gets borders right. Bottom gets bottom. And left gets left. These are just little helper functions to help with returning these values. Okay. Yeah, so that's our tile class, and I think it does all the things we need it to do for now. I guess to initialize one, I'd want to take the parsing a bit further. So unparsed tiles, map, do, we'll get both the ID line and then the unparsed tile data are the two pieces that are coming out of this, each piece of this tuple. And so then for the ID line, I guess I just want to call match on it to get the ID line match. We'll have a regular expression that matches on some number of digits, and we'll do a named capture group here. ID. That'll be that. Yeah, so this will just be match group, for lack of a better name. And then the unparsed tile data, we will split on new lines. And then we will map that. And each line will be split on an empty string, and that'll create our 2D array. And I think we can initialize our tiles from here. So tile.new, match group.id, and then tile data. Okay, so those are our tiles. Eventually we're going to get some sort of rules. Result 0, and then we're going to put out the result. And I'm going to pry in here and see how the parsing's going. Uninitialized constant tile. That makes sense. We probably need to define tile first, so I'm just going to move tile to the top and push all of this down here. Okay, and we'll give that another try. Undefined method ID for match data. Okay, it wants us to do a hash-like access, I guess. Okay, tiles.first. That looks pretty good. Orientation 0, flipped false. That's the ID. Top is dot hash hash dot 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 hash hash dot dot. Then the right should be 4 dot hash, 4, then a dot, then a hash, 4 dots and a hash for the bottom. Yeah, this is all looking good. Say tile dot first dot rotate. Whoops. Does that look right? The left became the reverse of the top. Yeah. The top became the right. Is that same? Mm-hmm. Okay. Flip. Yeah, we're now at 90 degrees, flip to true. Now at 270, and then back to 0 again. Okay, I like how this is operating so far. Let's pop out of there. So that was a lot of setup to get the tile data structure in place, but I think that's gonna help a lot in the next phase of this. So I guess the next piece of this is, wow, gonna be starting to explore the problem space of possible tile placements. And I think that really is going to be kind of the hard part here. So I guess the one thing we can know is like the size of our grid. So we can say tiles.count .size, and we can say math.square root to I. Grid size. So I think in our case, it's gonna, there's 144 of these. So it's gonna be a grid size of 12. It's gonna be a 12 by 12 grid. And we can take that and generate an array of arrays. We'll say s_nil and multiply that by grid size, and then wrap that, multiply that in grid size, and that's our grid. Is that gonna work? Yeah, cool. There's a 12 by 12 grid. So then we can just go one by one, and if there's a nil, we can put something in it, then we go to the next, and so on and so forth. Yeah, I'm trying to think how we approach this. I mean, I think we're going to need some sort of recursive function if we're going to be able to kind of like explore all choices and be able to do some sort of backtracking. So imagining place tiles, and we're given available tiles, current grid, and I don't know if we need anything else besides that. And yeah, knowing that, we would take available tiles. Oh, I have a curiosity, so just a quick pry. If I have 5 like this, I'm just curious about a Ruby destructuring thing. Can I say I and then rest? Okay, and then what if I say a rest gets okay, and then a rest. Oh, that's awesome. Okay. Sometimes I forget that Ruby actually has some pretty solid destructuring stuff. I mean, it's not as fancy or robust rather as I think ES6 JavaScript has some more things up its sleeve. Certainly things like Elixir and Rescript have some stronger offerings, but Ruby will still get you pretty far. So next tile, remaining tiles. So we'll destructure that out. And if I think at this point, if next tiles is nil, then we've like found an answer. So yeah, trying to think how to if next tiles dot nil. I don't think that that we have to find some sort of way to like early exit out of all of this, but I'm going to put this as a placeholder until I figure out what that is. What are the other exit cases? I'm not sure yet, but okay. So if we're empty, then we found the answer. Otherwise, what do we do? Well, we take, next tiles. Sorry, that's a misleading name. It's just next tile. We take that next tile, and in its sort of initial orientation, we would something that just got me thinking is I wonder if we need some sort of method on here that's like reset, that puts it back into its initial orientation. Yeah, I'm not sure. That's just something to keep in mind. Its initial orientation and unflipped. Okay. Oops. Sure, I'm jumping around. So I don't know if I'll need a reset, but that was just something that came to mind here. What we do need to do though is, I guess, find the next open grid position and try placing next tile into that position. And I guess if it doesn't fit in any of the positions, then we would still need to hang on to the next tile I guess we just dip into the remaining tiles then. But next tile could still be part of like a later placement solution. Maybe pulling these apart isn't doing us anything. Maybe I get rid of that and I just say if available tiles dot empty. If there's none left, then we've found our answer. Extract it from the current grid. Def, yeah, would grid benefit from being turned into a class maybe? We could try. Yeah, let's do that. Def grid, how about class grid? Def initialize. And that takes in a size. Yeah, I guess just a size. And so then we can do this line up in here. Okay. And the reason I want to put this in a class is because then I can say four corners, and we could grab the four corners out of here. Grid 0, 0 would be the first corner. Grid, use some Rubyisms here. First. Grid first, last. So that'd be first, last, first, then, then last first, and then last. Okay. Last. Okay. So that would be the four corners, and then I guess the corners product. I don't know. Does this thing need to be able to? Yeah, might as well. So. Four corners, map, and a tile for each. So if tile nil, then we raise something because that's not going to work. So raise grid is incomplete, something like that. Else we get tile.id 2i, and then we do a reduce over the multiplication. What is this indentation? I don't know why that's happening. Use 2, not -5 spaces for indentation. What's it talking about? Oops. Equal. That's very strange. I guess using a guard clause fixed it. Sure. Okay. Corners product, 4 corners. I guess the grid could tell us next open position. Yeah, we could either keep track of that state or we could just, you know, traverse it and find it real quick. So kind of prefer that. That way we don't have to worry about that state getting out of sync somehow. So say grid dot find. Yeah, we need an X and a Y here, so I guess grid dot find row dot include nil. This would be our X, and then Y would be the, am I getting X and Y mixed up again? Yeah, I am. That would be, the row would be our Y. And then the X would be the position in that row. So, oops. Or yeah, grid Y. Find something like that. Find nil, and then I return the XY. Huh. I'm not liking the way the X and the Y are coming out, because even though I think I'm calling the right thing here, the positioning them X first and Y second seems like I'm gonna mess up using those to access, because I imagine later going, okay, so grid X, grid Y, and that seems backwards, right? But yeah, you want your X-axis to be, I have that mixed up. Yeah, so horizontal. So yeah, I guess the reason it's confusing for me in this moment is because just because of the way that the grid is constructed, not because I have the concepts mixed up. So yeah, how should I return these in that case? I guess I should return them YX, since that's how I'm going to want to access the grid. So next open position, we get back these. Okay. So we'll say to initialize our grid. Like that. And then that'll get passed in here. And so since that's a grid object, we can say grid.next open position. I hate this already, but we're just gonna have to remember that that's how we're thinking about these. So then grid do I need a way of accessing the grid object on grid, or do I just want to define something that maybe I don't even need to know about these, and I just need to say place tile in next. Yeah, what if instead I did try tile in next position, and I gave it, you know, available tiles dot first. So if I did that, then it could take a tile, and we would check, I guess we'd actually call next open position, and then we'd say, I don't know, grid y x gets gets tile, and if grid dot valid, then like, I don't know, continue, else grid yx goes back to nil. So if it's not valid, then reset that and return false. Otherwise return true. So we need a way of checking if it's valid. Do we need to actually set the tile on the position to check if it's valid, or should we just ask, like, is tile valid for position? And we get a tile, and a y and an x. And then we would like find top, right, left, bottom neighbors, check if tile matches with each that isn't nil, and then return true or false. That's what this would do. And so, yeah, then I guess here we could say, is tile valid for position? Tile position, tile yx. If it is, then set it, else nothing, turn false, turn true. No, so that goes away. Yeah, how about like that? So, yeah, I think we're kind of getting to the meat of the problem here. So, find neighboring tiles for yx, so that could return an array. And then, oh, but we need to have a little more insight than that, because if we're comparing the tile above our current position, then that's like comparing the top of this tile to the bottom of that tile. So maybe we just put the tile finding smarts in here. So yeah, grid y, x. Now let's see, top would be the same x position, but a different less than 1 y. So y minus 1 would be top tile. And yeah, I think we can raise an error if this happens. So let's see. Like if I ask for the -1, I get nil. If I ask for the third, I get nil. Oh, maybe not. I don't know why I was thinking I would raise an error. Oh, that's great. Okay. Well, in that case, we just do these access checks, and if these things come back as nil, then the validity is just necessarily true, because it's either like a tile we haven't set yet at that in that direction, or we're at the edge where we don't need a match. So then the bottom tile would be +1. Oops, bottom. Then the right tile would be yx +1. And then the left tile would be x minus 1. Okay. So we find each of those. Then we check if tile matches with each that isn't nil. So yeah, how do we do this? Top tile and top tile dot. You want the bottom of the top tile. So top tile dot bottom equals tile dot top. Okay. So if that's true, yeah, it's like this whole thing, and then it's bottom tile, and so at any point we could short circuit here. Although if these are nil, then let's see. Yeah, it can be nil, or it can be so top tile will do that, and if it's defined, then we do the comparison. If it's not defined, then we say true. Okay. So we'll do a ternary to figure this out. Bottom tile dot top gets tile dot bottom, otherwise true. We're going to continue like that. Okay, and then the right tile. So the right tile, we want to compare its left to be equal to the tile dot right, otherwise true. And then lastly, the left tile, compare its right side to the left of the current tile, otherwise true. And that just whole check gets returned, and that'll tell us, is tile valid for position? If it is, then we set it and we continue. Yeah. Okay. So yeah, we'll do that. What's it complaining about here? Oops. Okay. So where were we down here? Try tile in next position. If that works, then still need to figure out how we consider all available tiles. I guess we say like available tiles dot each. Yeah, available tiles dot each. Current tile. And then if we compare that one, and if it's true, then we call place tiles for, I guess, like available tiles, remove current tile, something like that. Followed by the, what am I calling big grid there? Current grid with the updated grid. Else. Yeah, so if it doesn't, if that tile doesn't fit, then we'll just iterate on to the next one. If it does fit, then we'll place it and we'll keep going. We also need to consider all orientations of the tile. Try tile in next position. Do I want to try all of the do I want to like do the rotations of the tile here, or do I want to push that up into the grid? Kind of feel like the grid shouldn't know about that. So maybe what I do is say current tile dot how do you iterate over all the valid positions of the tile? I don't know, do I enumerate them, or do I just know that it's 8 and do like 8 dot times? Yeah, this is tricky. I think trying to keep these things in, or knowing that we're going to be continually changing the state of these objects. It's making me wonder of the best way to do this. I guess this tile comes in and it's like initial orientation and it's unflipped. We try passing it in. If that doesn't work, then we should flip it up to 4 times. Otherwise, we should rotate it up to 4 times. And if that still doesn't fit, then we should try flipping it and then rotating it a few times. I wonder. I kind of have a curiosity. If I pry in here, oops, not that kind of pry. If I run this and I pry in here, and then I have tiles.first, can I say tiles.first.dupe new tile? And is that F498? Yeah, that's different. Okay, so I can say new tile.rotate and tiles.first. Yeah, is not affected. Okay. So I guess what I'm thinking with that duplicating object idea is that each time we're about to work with a tile, we can create the 8 orientations of it. Yeah, so sorry, I don't know where to put this. Create 8 orientations of a given tile. And so we'll have tile dot dupe dot rotate tile.dupe dot rotate. This is probably a silly way to do this, but rotate. So that'll give us our 4 initial orientations, and then if we say tile.dupe.flip, then we can say rotate, and then rotate. Whoops. Yeah, I think I got all of those. And then all of those appropriately, and yeah, I think we have a thing that works. So create 8 orientations. Say tile.create 8 orientations of current tile dot each do I don't know, oriented current tile. How's that for a name? And so if one of those matches, then the thing we'll remove from available tiles is the current tile, which is going to have an object ID that matches what's in available tiles. If I pry in here again, say tiles, tiles.first, it's 3469. Okay, so if I say tiles dot, it's not remove, it's delete. Yeah. Tiles dot size, 143. Okay. And if I say tiles dot first dot dupe, it's nil because yeah, there's nothing in there that matches. Okay. Okay. So if that fits, then we delete it. Although modifying this available tiles, deleting things from it each time. Yeah, I wonder if deleting it is going to be destructive. I wonder if there's a way to just like pass in something that filters it out. Yeah, what if I say available tiles dot filter next tile set gets available tiles dot filter is not equal current tile. How about that? And then we can just pass in next tile set current grid. Okay. So then that's going to go in. It's going to try all these. If it fits, it keeps trying things. Eventually, we're going to get to the end of the line here. Yeah, nothing's going to fit. We're going to get down here. And what do we do then if we're working with kind of limited space? Let's open it up. Okay. So if we get down here and we haven't found all of our matches, then yeah, maybe there's, I think that would be our like no solution found case. I guess the winning case can now be current grid dot what was it? Dot corners product. So then whoever calls place tiles like that. Maybe we need to put place tiles up above all of this. Sure. I guess raise standard error. No answer found. So for each available tile, the first time we enter in here, we've got an empty grid. We'll take each available tile and we're gonna are we gonna try each available tile as the starting tile? I mean, that would be the only way. Is that how this will work? Or yeah, I think this function isn't gonna quite do what we need it to in its current form. It's like this is the initiating function, and then there's a different one that it calls that's like the recursive function. Not sure if that makes sense, but I'm vaguely remembering that that's sort of like a pattern that I've noticed when building sort of tree traversal, recursive tree traversal things. So yeah, I'm kind of getting to a point where this is all pretty like conceptual, and I need to get more of a like hands-on understanding of whether this is working or not. I mean, maybe we can. Yeah, I think I know what I want to do. I want to grab this input here, the smaller sample input, and see if we can get anything running with that. I say sample.txt, paste that in. Okay. So what happens if I run this then? Get tiles. Oops. Yeah, that looks pretty good. Then grid. Yeah, that looks pretty good. So then place tiles, grid. Right, undefined method rotate for hash. That's interesting. For hash. How's that getting called with a hash? Let's see, so that was happening when create orientation was called, and that was getting called with current tile, which is available tiles.each. Oh, it doesn't like us prying in there. Okay. That seems fine. So tile.rotate. Oh, because rotate isn't returning self, it's returning this thing. Okay. So what if we call this now? Just have those rotate and flipped return themselves so that they can be chained together. No, plus a conversion of array into integer. Into array into integer in next open position 120. Oh, why is a index? That's what I want. Okay. Is tile valid? 95. Conversion from nil to integer. Uh-oh. Let's see, 95. Oh, sure. Yeah, so if y is 0, then that's going to be -1, so it's just going to be nil. So you can't say do an array access on nil. Right, so maybe we say something like, oops, call array on each of these. So then if it does respond with nil, then it'll be turned into an empty array, and then the second array access on the empty array will then turn into nil. At least I thought that's how it would work. So if I say array for still a 95 is tile for valid position. Is there something wrong with grid? Is grid nil? I mean, it can't be. It gets initialized here. Array. That's interesting. Well, let's see if we can pry in there. Okay. Tile. Great. Y, X. Why does X come in as nil? Oh. Okay. I think I know why X is coming in as nil. So what was that index call? Yeah, this is the same thing. We're trying to find index. Should have caught that before. Y, X, okay. Tile, exit. Get rid of that binding and give this another run. No answer found. Okay. So we found some grid placements. Yeah, but the last one didn't work, and so what's our, yeah. So it placed this was the first thing that came in, 2311. It placed that in the first position and went from there. Is it even working? Does this first tile, does its right match up with this other one's left? Dot, 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 dot. Yeah, sure enough. So, okay, we've got something that's like vaguely working, but if 2311 wasn't a good fit here, then I need the algorithm to like back out and put something else here and shuffle 2311 in to a different spot. And instead we end up bailing. So that's the piece that I think is missing for me at this point. Yeah, it's like, it's almost like I need to call place available tiles with like the first, it's like I want a different starting tile to come in each time, if that makes sense. I mean, is that what's happening here? We take the current tiles and we get all the orientations of them and we try them all. And if it doesn't work, then we go to the next tile and we're still considering all available tiles as a thing. Yeah, I think what's happening is grid is getting, the state of grid is getting fixed in place. So we need like a I don't know, new grid, dupe grid. That's new grid like dupe. So if I do that, then what are we checking current grid right here? Seems like, okay, dupe grid. That gets checked there as well. Okay. What about if we run that now? Still no answer found. If we duplicate the current grid, then we can try a bunch of different, yeah, then for each of the available tiles that we try, we'll reduplicate the current grid so that we're sort of working with a fresh slate. Yeah, but instead we're popping out with no answer found before we've had a chance to try other possibilities, I guess. You know, I almost want to say raise standard error answer found and see if that does it. Yeah, no answer found. Okay. I guess what I was starting to worry about there is that I was getting to a point, an endpoint where the answer was found, and I was returning that, and then this was going to completion, and then falling out, and that we were raising a different standard error instead of seeing what that answer was. So instead, if we get to this point, I'd like to raise a standard error with our answer as a way of sort of short-circuiting the rest of the search. but it seems like we're not even getting that far. Yeah, is there something else we need to do here? We take all the orientations, we try them out. If it fits into the dupe grid, then I don't know, do we actually need to put dupe grid inside of here? Still didn't like that. Just want to make sure that for each iteration we're working with kind of a clean current version of the grid. One that hasn't had sort of other stuff applied to it. So if this tile fits in, then try filter the tile out and place more tiles. Otherwise keep going. I feel like it's doing what I want it to do. So I'm not sure what's going wrong. I think that's our problem. Let's try this now. Well, we're getting a little further. No implicit conversion from nil to integer. Next open position on 120. Why? Okay, so why don't we call a next open position where we wouldn't have a next open position? That's weird. I guess if y comes back as nil, then we weren't able to find the next position, so then try tile a next position. Oh, that's strange. What if we were to raise standard error, no more open positions? So if we did that, actually maybe we need a better error. No open positions. Standard error. So we'll raise that instead. And then we can do if. Can an if have a rescue? Okay. I'd like to pry in here and see what things look like at that point. No, that's not going to buy me anything. Okay. Unexpected. Oh, I guess I do need to. Okay, I guess you again. What we can do. Let's try that. Okay. Yeah, I know, but why didn't you hit my rescue? 122. No open positions. The only place that calls this is try tile. The only place that calls this is, oh, whoops. Gotta wrap that around the whole thing. Okay. Where am I? There we go. So where are we at that current grid? So how can you say there's no open positions? Oh, what about dupe grid? Dupe grid at oriented current tile. Oh no, I made a mistake. No open if y no. Without that, we're just calling it every time. Whoops. On that exit, run as tiles. Okay. Now we're in here. Now we presumably actually reached a place where yeah, I mean, they're all filled in. Is this, I don't think this is a valid orientation of these things though. Dupe grid dot, corners product. Undefined method ID for tile. Tiles dot first. Oh, sure enough, I didn't. Okay, so we're gonna hit this a bunch. That's interesting. Probably 9 times. Maybe a lot more. Why are we ending up with, why is it filling the grid in those cases? Yeah, that seems wrong to me that it's filling the grid. Class tile needs to be able to return its ID. Do that instead. Okay, and then $506,761. I mean, I don't think that's right. No, not even close. So how did it fill it up if try tile in next position? Oriented current tile. Grid dot. So the first thing it put in here was 2311. So how is the current tile 2311? That's pretty strange. So a little confused about what I'm seeing, and I'm struggling to debug this a little bit. I'm not sure what I need to be able to better debug it though, because we're getting in here. How is it that we're trying to place a tile when the grid is already full? It seems like we're ending up with some version of the current grid that is it seems like this grid is getting fully populated on some first pass through the tiles that we check. And then as we're like checking different iterations of them, it is we're continuing to try and place things in there. If that makes sense. Yeah, why are we at a point where all 9 tiles are available and the grid is full up? Available tiles should be empty at this point. Unless trying the 8 orientations is So I can get rid of that pry because that's not helping. Still curious about that one. But first I'd like to just do some print line debugging. So place tiles is called double tiles that size, and then current grid dot available spots. I kind of want to create a function on grid that can tell us the number of available spots. Something that'll work kind of similar to this. Available spots, and I guess grid dot grid dot sum row, and then grid dot count nil. I think that'll do. And then here we can say, can put our arrays here if available spots equals 0. Okay. So we've got this puts. I guess I'd also like to puts the checking tiles, and I like to get the current tile.id. If I do all that, that's enlightening. Place tiles is called with, why is grid starting out full? That is truly not what I was expecting. Grid dot available spots is empty. Yeah, something is going completely wrong. Grid gets a new grid. Initialize. So, oh, what's the next one? So we're initializing with a bunch of nil. So how is it ending up full right away? That is puzzling. On the first pass, grid size, grid, not doing anything else before that. This is just a function call. That's our method, and this is our class. So how does our first pass into here have us with a grid that's full? Available spots. Count the number that are nil. Kind of want to call available spots from the outset, so let's initial available spots. Oops. Okay, now if we run that, initial available spots is 0. Is there something wrong with my logic of saying some row dot count the number that are nil? So how are we ending up with 0 on I don't know. Class grid. I'd like a outer accessor for grid. So I can take another peek inside of here. Actually, I'd really like to know what's going on at this point. So available spots is 0. So did I implement it wrong? Grid, give me the sum. Oh goodness. Okay. Whew. Okay, now we're seeing some actual progress. 9 for 9 places it. Now we've got 8 tiles remaining, and yeah, this is a problem. 8 tiles remaining and only 6 spots available. So something happened to our grid in this first pass. That's pretty strange. I have a suspicion that well, let me take another look at that output. So check 1 tile, but then we get here and 6. Okay. So yeah, we check tiles. So then is it possible that 3 different tiles are getting injected into 3 different orientations of the first tile are getting injected into the duplicate grid, and that's why we have available spots coming out as 6? I don't know. If dupe grid, try the tile in the next position. Yeah, if that returns true, then like it should call into here, but how is it that at this point dupe grid is... Oh man. Let's put our pry there. Gotta get rid of that one. Okay, so current grid, available spots. Yeah, it's 9. That's great. So now 9, 9, checking 2, 3, 1. So what does current grid look like? So 2, 3, 1 got placed in 3 different places? How did that happen? It got placed at the first position of each of the rows. So is there some logic in, or an error in... Yeah, let's see this try tile at... Stick it in the YX. How would that put it in the first position of each of the rows? That should just be a single cell entry. Is tile for valid position? Try tile in next position. Huh. How is that happening? Don't need these duplicate returns. I guess, how many times is this getting called? Placing a tile at y, x. Boy, we are doing some print line debugging now. Yes. Okay, let it run. Whoops. Placing a tile at 0, 0. So then why does current grid have that placed at 1, 0 and 2, 0 as well? What about dupe grid? No, we don't have that in that context yet. Current grid. Place tiles. I say current grid dot dupe. Okay, but flipped. I mean, all these things with the same orientation and everything. I'm finding this pretty baffling. I must be doing some small, silly thing to have these tiles show up at 3 different spots, but I can't see it. Try tile in the next position. Yeah. So what if we give it another loop around? 8, 6. Check all these tiles. We finally find one that we can place at 0, 1. And we do. So then what does the current grid look like? Oh, it's doing the same thing. Oh, are these arrays? Oh, I just had a thing that I'm worried about. Stuff, if I say this is L times 2 times 2. Okay, and so if I say stuff 0, 0 gets, why is this in 2 places? And what does stuff look like? Oh no. So I made a fatal flaw of creating an array of duplicate arrays, which means when I insert into one place, I insert into the other. Oh man, that's unfortunate. So how am I gonna, I thought this was like some really clever syntax, but I shot myself in the foot with it, as a person is wont to do when being clever. So how should I do this differently? I guess I could say, 3 dot times do 3 dot times do or let's try that again. Stuff gets an empty array. 3 dot times do stuff gets subarray gets this. 3 dot times do subarray gets nil. Stuff gets subarray. Okay, so we do something like that. Class grid get rid of that awful code that is ruining my day. Save that, and let's give this whole thing another run. Stuff, whoops. How about like that? Nine, placing a tile at 0, 0. 8, 8, placing a, okay, so this is feeling more promising. So then if we get rid of that binding and we let the thing run. Oops, go away. Print out a bunch of tiles. Do we ever get an answer? Seems like not. Why do we print these tiles out? What's the result? Maybe that's why. Did our place tiles just return a pile of tiles? Because, oh, that's possible. Each. Yeah. Huh. So it didn't find an answer, it returned a bunch of tiles, and it bailed. In that case, yeah, that was kind of what I was suspecting before, that the this sort of iteration of the available tiles isn't going to, yeah, I was worried that wouldn't work. So place tiles. So if I get to the end here and I return nil, or we return the product. Or no, I do like the raise. That'll help us short circuit. So then I want to have place tiles taken, available tiles, and grid. And then I want to call available tiles dot size dot times 2i. Yeah, I think that'll work. And then I can say available tiles dot rotate I, and that's what I'll call with recursive place tiles and grid dot loop. So no open position. So what's current grid dot corners product? 2511. No. 2511. No. Not sure why we keep hitting that position. That raise is not something I was expecting to hit really at all, because I thought where is it? Yeah. I guess I thought if there were no available spots that the yeah, I thought if there were no available spots that the this would hit instead of it getting down into here. So I wonder how it is that what is that 9? That's not that many iteration. Oh, oops. Recursive place tiles. No, that's part of the problem. Recursive. How about we call that recursive? That's still zipping along and not returning a useful answer. Huh. Just seems like this whole thing is exiting too early. You know, instead of trying, I don't know, what, like eight different orientations of 9 different things. I don't know, is that like to the 9th power because there's 9 different tiles? Like, seems like it should be some big silly number like that. That's like how many combinations it could like exhaustively check. I mean, I know it backtracks pretty frequently, but still. 9 tiles to place, 0. That's weird. It gets filled up and then it's just stuck. So what's happening that the grid is just getting stuck like that? I guess if you place the tile, I thought dupe grid would be getting replaced each time here as we like iterate around. It seems like it's not though. Grid dot available spots. Kind of curious if this something weird's happening with the state of this thing, and oh wow. So way up here it had 1 free spot, then it got stuck and it just never had free spots again. So yeah, we've done something wrong there. I guess if we're coming out of here, I'd like to know what like what the position is. So if we can have this return either false or yx, and then we can have like grid remove. Just say grid y x gets nil. So if that returns a position, then we have the latest position. If we come back out of here, then something didn't finish, so we say dupe grid dot remove position. Oh. 2089 3289. Hey, there's an answer. Okay, so the logic was good. We just had some weird state problems. Well, in that case, let's get out of here and oops, where's our file dot? Yeah. Let's set this to an input and see if it can handle a 12 by 12 grid. Ooh. Yeah, I'm a little worried about how much this is going to try and run. Yeah, there's a lot of there's a lot of problem space to search, so this could definitely run for a while. I think part of the problem too could be all the console logging we're doing to the terminal. That has a way of slowing things down. Kind of want to bail out of here, find all of the put statements. Cool. Let's give that another run, and we're not getting any sort of feedback this time since those put statements are running, but that also means that the terminal emulator isn't trying to keep up with all of those prints to standard out. So I do still expect it to be a bit of an expensive operation, so we'll let it run, but there, it spit something out. Let's see if that's our answer. And, ooh, we got a gold star. That was quite the problem to solve. There were so many moving pieces. I'm glad to see we could figure out an answer though. Thanks for watching.